Okay, so you can see polynomial. This is your cubic polynomial. So it is very important. You see divisible. Divisible maksudnya boleh dibahagi sepenuhnya. Boleh dibahagi sepenuhnya. Reminder dia kosong. Find the value PQ. Hence, only you factorize your polynomial completely. So from your divisible means your divisor here is a quadratic. So from this quadratic you will have two linear. When you factorize here, you can see what is the divisor number here. So your divisible number here is x equals to 4 over 3, another number x equals to 1. So means that when we want to use our remainder theorem, we need to find out what is our x value here, what's our divisible numbers here. So from our divisible quadratic, we find out the divisible x number here is 4 over 3 and 1. And then from the factor theorem, we can substitute when p 4 over 3 will equals to 0 because we said divisible means nothing left, no remainder anymore. And another equation is p1 equals to 0. So this is our factor theorems means. From the x value we put in, you get 0 is a factor theorem. If you get value, means when you divide by this thing, when you divide by this factor, it will leaving you a remainder. Okay, so from there, you find out your value PQ. So this question is testing on our 6.2 concept. So we substitute our x into our polynomial, where our first x value is 4 over 3. So this will be our first equation. We simplify it to get, here we'll get negative 4p and then negative 3q equals to negative 82. Alright, you can simplify it one by one. What's the value of this? Okay, so we can do it one by one. So we will remove the denominator time with 9. So here we'll times 3. And we simplify it. Simplify this equation, we can divide by 4. So this will be our first simultaneous equation. We continue for another divisor here. Our divisor from x, divisor x minus 1. So the x value is equal to 1. So put in into our polynomial P1. Okay, so we get our second equation here. In order to simplify our simultaneous equation, we make it same. In order for us to eliminate the value of Q. Okay, so from here we can start doing 1 minus 2. We can eliminate Q, we get P only. Then we can substitute back into the equation, find out the Q. So I can substitute back to the easier equation here, this one. Then question 6, hence you have to factorize it completely. So means you have to use our PQ in our polynomial. So your polynomial now, it is equals to 12x cubed. So your P is 22. And then your Q is negative 2 become positive. To factorize it completely, so one of the factor is this, because we said it can divisible, means it no longer. So one of the factor is this. So you can see here, when your cubic polynomial, one is a factor is quadratic, so we have to find out another factor is what? What is the another factor? So you can see 12x cubed minus 22x squared plus 2x plus 8 actually is equals to one of the divisible here is 3x squared. This will be in the polynomial factor forms. From cubic, when you factorize, you will have 3 linear or quadratic with 1 linear. So from here, we can do the division. Either we can do this long division in order to find out this polynomial, or we expand, we compare back what is our mn here. So we have two methods to solve here. Okay, so I show you the first method, whether we can divide it. We do the long division. And then divide this quadratic factor in order to find out what is another factor. So we can get here 4x. So 4x times 3x squared get 12x cubed. Then 4x times this, negative 28x squared. Then 4x times 4, 16x. Okay, so minus here we get positive 6x squared. So minus here we get negative 14. Then here is nothing, so 8 minus 0 we get 8. So we continue another level of division. We still can divide, because x squared with x squared we can still divide. So we need a number 2 here. When 2 times 3x squared, 6x squared. So you can see it completely divided here, nothing left. So means that our polynomial is equals to divisor is this quotient. So no more divisor. So we can see factorize completely. We take the quadratic here and factorize it completely. And we can see this even number still can factorize it. So this is what we mean factorize completely. So cubic, normally we will have 3 linear factors. So that will be our first method. We do it by long division. Another method, we can do it by comparing. So we can expand, we expand this to compare that. So this is in our factor form, this is our expanded form polynomial. So we try to expand for the right hand side. Okay, so try to expand, you can see this one, 3x squared times here will be 3mx cubed. So straight away we can see the comparison, what's your m, because the coefficient of the x cubed is 12. So you can see 3m is equals to 12 actually, so m is equals to 4. Then we continue to expand. This 3x squared with n will become 3nx squared, but we cannot compare yet because we still have another x7 expand. So the first multiply, expand to the back, then go for second term here, negative 7x times here. So it will become negative 7n squared. Then negative 7x times n, negative 7nx. And then this one 4. Lastly 4n. So the most easier we can compare is the last part, the constant part. When we compare the constant part here, 4n equals to 8, so n equals to 2. Then we also can factorize our polynomial completely, which is equals to one of the factor is quadratic. Another factor here is a linear. So the procedure is still same. Factorize out the value of 2 and then quadratic, factorize it completely. Okay, so this is how we use our factor theorem and the concept of factorize completely. So actually this is our theorem. This is our theorem. When you want to write equals to 0 or equals to a value, equals to 0 is a factor theorem. So this is your basic. And when we substitute our x value, we are using our factor theorem. So both of them are your concept, and solve our simultaneous equation to get both answer. So lastly, how you factorize it completely is, it depends on which method you use. If you use long division, so this is our method of long division, and then to get out what is another linear factor and make sure it is factorized completely. For the quadratic part also we need to factorize it. So if you use comparison here, where we expand the factor and we compare, so this is our method, compare and answer.